Okay, so we are starting chapter 2. 2.1 is writing and graphing inequalities. So now we're switching from equations to inequalities. Our equations where we had something equal to something. Inequalities are going to be where you have one side that's greater than the other side, less than the other side, greater than or equal to, less than or equal to. So an inequality is going to show which expression is greater. Okay. Let's see. Solution of the inequality is going to be all the answers that make the inequality true. So if we have x is greater than 2, then that means any number greater than 2 is going to be part of our solution set. So the solution set are all the answers that would make that inequality true. Our graph of the inequality is going to give us a visual representation of all the solutions. So instead of writing it down algebraically, we can show what's happening with a picture so we can visually see what is going on with this. Okay. So inequalities, x is less than 2 would be how we would read this inequality. Notice that the less than symbol that we have right there kind of looks like an L squished on its side. If you can visualize an L, and then we have our less than sign, they're very similar to each other. So that's one way to keep track that this is a less than sign, whereas the next one is a greater than sign. It does not look like an L squished on its side. It would be backwards. If it has the line underneath it, like this one does here, that means less than or equal to. So if I have x is less than 2 or x is less than or equal to 2, the only difference is whether 2 is included or not. So on this first one up here, 2 was not included. So we have an open circle to show that all the numbers coming up to 2 are included, but 2 itself is not actually part of the solution set. Whereas when we come down here, to this one, all of these numbers over here are solutions, but this one right here also shows that 2 itself is actually a solution. So on this top one, 1.999999999 would be a solution, but not 2. Down here, 2 would be included with that solution. So that's how we show when it's equal to, we would have a closed-in circle. And if it's not equal to, we would have the open circle to show it includes everything up to that number, but doesn't actually include that number. And then we've got greater than or equal to. So it would include 2, and then it would include all the numbers greater than it going in that direction. Okay, so here's just your reminder on when you use the open or the closed circle that we just talked about. This notation right here is just a fancy way of writing this. You won't be expected to write it in this format over here. Writing it like this is great, but you do want to recognize in case this format shows up that you are aware that it is the exact same thing. All right, so we're starting off by writing the sentence as an inequality. So it says 12 is greater than or equal to 5 times the number n. So we're just going to read it one piece at a time. So it says 12, and then it says is greater than or equal to. Greater than or equal to would be this symbol here. And it's greater than or equal to 5 times the number n. 5 times the number n we could write as 5n. That's it. That's all it's asking us to do, writing it as an inequality. On number 2, it says 1/3 of a number. So we can write the 1/3. Anytime you see the word of, that's a clue that you're going to be talking about multiplication. So 1/3 of a number means 1/3 times 8. And it says that it is less than 15. So we have less than and 15. And that's it. That's what we have for that problem. Okay. All right, go ahead and pause the video. See if you can try the next 2 on your own, and then come back in once you think you've got it. Okay, so 7 is less than or equal to the difference of a number q and 6. Difference means subtraction, so we're actually going to be subtracting q minus 6. Notice q minus 6 is different than 6 minus q. This one here would not be accurate. It's q and 6 that are being subtracted, so q needs to be listed first and not the 6. Think of it this way. If I have 3 minus 2, that's equal to 1. But if I have 2 minus 3, that's equal to -1. So the order does make a difference. They're not the same thing. The sum of a number u and 14 is more than 6. Sum means addition. So we're going to be adding u and 14. And it says it is more than, which would be this symbol, 6. On this one, addition, the order doesn't make a difference. So it would be fine for you to write it either one of those ways. All right, next one, tell whether the value is a solution of the inequality. This is just saying basically if I were to plug this in for my d, would I get a true statement or not? So it tells me to plug in a 19 for D. So I have 19 minus 7 is less than 12. 19 minus 7 is 12. Is 12 less than 12? No, 12 is equal to 12. So this is not a true statement. So if we want to know if D equals 19 is a solution, we would say no, it's not a solution. On number 6, same thing. We're now going to plug in a 1 wherever we see our n. So we have 9 is greater than or equal to 3 times 1 plus 6. 3 times 1 is 3. 3 plus 6 is 9. So now I have 9 is greater than or equal to 9. Well, 9 isn't greater than 9, but it is equal to 9. And so since it could be greater than or it could be equal to, we know that it is, in fact, a solution for it. Okay. So now we're going to be graphing the inequality. So we have x is greater than or equal to 3. So the first thing is we identify where 3 is. And then we need to decide, should it be an open or a closed circle? Because it's greater than or equal to, it's going to be a filled in closed circle. We want to show that 3 is actually part of the solution set. And because it's greater than or equal to 3, our arrow is going to go to the right. Okay. Notice that this kind of looks like an arrow pointing to the right, and that was the direction that we drew our arrow. This will always hold true as long as your variable is on the left-hand side. If your variable is on the right-hand side, then it needs to be flipped. Okay, on the next one, x is less than or equal to 4. Go ahead and try graphing it, pause it, and when you're done, come back and check and see how you did. So x is less than or equal to 4. We would have a closed circle because it's less than or equal to, and because we want less than, we would show that it's everything going to the left. All right, try 9 and 10, and then come back and see how you did. Okay, number 9, x is greater than negative 1. So we would have an open circle this time on negative 1 because it's not greater than or equal to, it's just greater than. It means negative 1 is not actually included. And because it's greater than, we'd have the arrow going to the right. For number 10, we have x is less than 1. Again, this would be an open circle because it doesn't actually include 1, and it would be everything going to the left from there. Okay. So now we're going in reverse. They've given us the graph and we need to write the inequality. So it says write an inequality that represents the graph. So go ahead and give number 11 a try, pause it, and when you've got it, come back. All right, so we're going to use any variable, doesn't matter. So for example, x. So x is something compared to 1. We know that's how we're going to set it up. We look at it and the arrow is going to the right, so we know it's going to be greater than. It's an open circle, so we will not have the equal to sign underneath it. On number 12, again, when we have x compared to 0 this time, the arrow is going to the left, which means it is x is less than 0. Because it's an open circle, it doesn't actually include 0 in the answer, so we're going to leave it as just less than, not less than or equal to. Go ahead and try 13 and 14. Okay, so I have x compared to negative 3 this time. It's going to the right, so x is greater than. All these numbers over here are greater than negative 3. And because it's a closed circle, we do want to show that it's greater than or equal to. And number 14, we have x compared to 3 this time. It's a closed circle going to the left, so it'd be less than or equal to. Okay? All right, as usual, when we finish going over our notes for the day, you want to go back, star any that you had questions on, write a summary of what you learned so that you are taking that time to reflect on it, make sure you really understood it, and then come prepared tomorrow to ask those questions that you've got.